All right, guys. So we are beginning Unit 2, and that is all about equations. So before we can really start, let's talk about what an equation is. So we have been working with what we call, let me think of the word. My brain's empty right now. Not equations. Starts with an E. Not exponents. Oh my gosh, y'all, my brain is broken. We've been working with expressions. Expressions. Okay, sorry guys. So when we work with expressions, it's usually just a problem that we're solving without an equal sign. Now, equations are really similar, except for the only difference is that this is going to be a number sentence with an equal sign, and that equal sign must be in between two equal values. So, for example, if I had 2 plus 3 equals, what would I need to put on the other side of the equal sign to make it a true equation?
3 plus 2?
You could put 3 plus 2. Absolutely, that would be correct. You could also just put 5. So there's a lot of different options. You could put 3 plus 2. You could put 2 plus 3. You could put 4 plus 1. We're going to put 5 just so that we can see that these two numbers are going to add up to 5 as well. So on each side of the equal sign, we have a balanced equation. Both sides equal the same thing. Now, what if I had something like this? I have a number equals 5 times 2. What would I need to put over here to make this equation true? 10. That's all. All we're doing is making sure that whatever the value is on this first side of the equation, it must be equal to whatever the value is on the other side of the equation. So let's look at another one. What if I had 10 minus something, and on the other side of the equation, I had the number 2? What would I need to put in that blank spot to make this true? 8, exactly. When I take 8 away from 10, I end up with 2. So on my left side of the equation, I have 10 minus 8. The value of that is 2. On the right side of the equation, I have 2. So these are the same value. Finally, we'll do one more. What if I had 20 divided by 5 on one side? What would I need to put on the other side to make it true? 4. 20 divided by 5 is 4. Very good, guys. All right. Now, what if we had something a little different? What if we had an equation like this? 12 plus x equals 25. First of all, whenever we see something like an x in a math problem or in an equation, what do we know about this x?
It's a number, but we don't know what it is.
Yes, it's just a number. It's a number that we don't know the value of just yet. So there's a few things we could do to figure out what x is. But I'm going to start by giving you kind of a visual example. I like to think of an equation as a scale or a balance. And we know that whatever is on this side of the balance, it's got to be equal to the other side so that it stays balanced. We don't want one side to be heavier than the other and have a bigger value. We don't want side to be lighter to be lighter than the other and have a smaller value. So, what number would we have to add here to make this side also equal 25? 13. So if I were to put 12 plus 13 is equal to 25, my scale or my balance, it is going to be balanced. These are the same values. 12 plus 13 is the same as 25. Let me turn this light down a little. All right. So let's talk about what we actually did here to figure out that x was 13. I'm going to write this down here again. We have 12 plus x equals 25. What did we do to figure out that x needed to be 13?
I subtracted 12 from 25.
Yeah, you subtracted 12 from 25. So let's show that visually. You saw that we needed to have 12 and another number to make 25. So we know we've already got 12. So what you did is you started by taking 12 away. And 25 minus 12 is 13. Now, we need to make sure that both sides of our equation are equal. So whatever we do to one side, we have to do it to the other side as well. So if I take 12 away from this side, I need to also take 12 away from the other side here. So I'm going to subtract 12. And what is 12 minus 12? 12 minus 12. That's okay. It's going to be 0. So what we like to say here is that our 12s cancel out. I'm not going to write 0 plus x. I'm just going to cross them out because they cancel. And then I'm going to take my x and bring it down. And now I have a balanced equation that says x equals 13. And that would also be our answer for how to solve for x there.
So this won't be 13?
Just going to be 13. We would say x equals 13, and then we'd circle that. Now, if we wanted to make sure that we did get the right answer, we could then take our x value that we found. We found out that x is 13, and we could plug it back in to the original equation. And I'll show you what that would look like. So if my equation was 12 plus x equals 25, to make sure that I solved correctly, I could replace that x with 13, write 12 plus 13 equals 25. And now to make sure it's correct, I would just add these two together. What is 12 plus 13? It's 25. So I'd write 25 under here and another 25. And whenever we solve these, you're not going to have to go through this whole process. What I'm showing you here is kind of a visual representation of the thought process you might have to make sure your answer is correct. So what I would then do is look at this equation, 25 equals 25. Is that true? It is true. So we know that we did find the correct x value here. We know that 12 plus x equals 25. X will be 13. So let's go ahead and look at another example here before we try things on our own. What if we had x plus 10 equals 15? What would I need to do to solve this equation for x?
10 minus 15? No. No, never mind.
You're okay.
You can take that 15 away from 10.
So I would, are you wanting me to subtract 15 here?
No.
We need to add 5. 5 plus 10.
Ooh, okay, so we know that 5 plus 10 makes 15. But let's talk about what we would do, the whole process to figuring out 5 without just knowing 5 plus 10 is 15.
You'll take 15 minus 10.
Yes, so what I'm going to do here is I'm trying to get x to be by itself so that my equation becomes x equals something. I want to know what my x is. So I need to get rid of this plus 10, and I'm going to subtract 10 from both sides.
So I said it wrong when I said 10 minus 15.
Yes, you said it wrong, but I feel like I knew what you meant. All right, so when I have 10 minus 10, what's going to happen here on this side? I'm going to cross it out. The 10s cancel. Now I have 15 minus 10 on this side. What am I going to get? 5. Now all I have left to do is bring anything down that has not been touched. We don't want to lose any parts of our equation. So we have x equals 5. And that is our answer, guys. We know that if x is 5, we can plug it into that original equation. 5 plus 10 equals 15. And that is true, so we got the right answer. Okay, let's do one more example together similar to that. All right, I have x plus 6 equals 14. I want to figure out what x is. So what should I do first?
16 minus 6.
Yeah, I'm going to take away 6. Right here I have x plus 6, and I want to get x by itself. So in order to do that, we're going to take away 6. We're going to subtract 6, and we need to do that to both sides. And when we solve these equations, I want you guys to get in the habit of writing it exactly like this same setup. Okay, so what's going to happen with my plus 6 and my minus 6? They're going to cancel out, so I can cross them off. Now what's 14 minus 6? 8. And all I have left to do is bring down my x equals 8. Awesome. Okay, so we know that this is going to be the correct answer because if we plugged in 8 for x, we know that 8 plus 6 is equal to 14, guys. So good job. Okay, one more. I know I said that a minute ago. One more with me, and then I want you guys to try a couple by yourself. Let's do one where the answer is on the other side and see if we can figure out how to do that too. How about 12 equals x plus 16. Oops, well, okay, we're going to keep it. You're going to get a negative answer, by the way. I wanted to give you a different number, but I already wrote it. What would we need to do here first? Let's see. We're trying to figure out what x is. So we're going to do exactly what we did up here. We have x plus something, and we want to get x by itself. So we are going to subtract whatever that number is from both sides so that all we have left on that side is x. So in this case, we would take minus 16 on both sides. That's going to get rid of our 16s. They'll cancel out. And to figure out what x is, we just need to now solve what is 12 minus 16? Negative 4. Then we just bring down our equals x. And that would be our answer, guys. We figured out that x is negative 4. So we could plug that back into our equation and make sure it's true. Negative 4 plus 16. Is that equal to 12? It sure is. It sure is. Good, guys. Okay. Here's what I'm going to have you do now. I'm going to give you a couple of practice problems here. I want you guys to try to solve these on your own. So I'm going to give you a few minutes. I'm going to pause the recording. If you're watching at home, pause it and try it too. So let's talk about number 1. What is the first thing that we did in number 1? Yeah, we want to subtract 6. We have a positive 6 on this side, so to get rid of it, we subtract. What else do I need to do? Yes, those are going to cancel, Jenny, and then we are going to subtract 6 from both sides, because whatever we do to one side, we've got to do it to the other to keep it equal. So the 6's are gone. We're going to bring down our x equals, and what is 19 minus 6? 13. Did everybody get that? Awesome. Let's look at number 2. Okay, we have 23 is equal to 16 plus x. What are we going to do here?
Subtract the 16.
Yeah, let's subtract the 16 from both sides. Whatever you do to one side, you got to do to the other. 16s are going to cancel. Now what do I do? Yeah, what's 23 minus 16? 7. And we know that our answer is 7 equals x. So we circle that. Good. You got that one wrong? Uh-oh. Yeah, so let's talk about what would happen if we did that. That's all right. So if I subtracted 23 from both sides, then I would get 0 equals, what's the number here? Negative 7 plus x. So whenever you're solving an equation, you can still do it that way, but you have to remember that now we still don't have an answer yet. We have negative 7 plus x equals 0. So we would have another step to solve it here. We would have to just add 7 to get rid of that. It would cancel it out, plus 7. And then, I know this looks a little crazy, but it would end up being 7 equals x. We're not going to do it that way. We're going to get rid of whatever is next to the x first, and then get our answer like this. Okay, let's look at number 3. What'd we do?
I took that. Oh, sorry. No, go ahead. You took it. I took 37 from 23.
Okay, so you took 37 from 23. Let's think about that. If I subtract 37 from both sides, is that going to help me solve x quickly? It could if we then did the next step of reversing what we did, but we want to do the easiest thing. And the easiest thing here is knowing that we have a number plus 23 is going to give us the same thing as whatever makes 37. Yeah. Perfect. So you did find that it was 14.
Yeah.
Now let's talk about the best way, the most efficient process to finding that answer. What's my first step? Jenny, you said it a minute ago.
Minus 23.
Yes.
Right there.
We're going to take 23 away from this side.
And then put 23 over on that.
Yeah, and then we need to also subtract 23 from that side. Those cancel.
Bring the x, yeah.
Bring down our x equals 37 minus 23. You said it was 14. So guys, that is going to be our answer there. Whatever has the x on it, whatever side of the equation, we want to try to get rid of everything else, because our goal here is to get x by itself. Our goal is to get x by itself. So let's look at number 4 now. We have x plus 21 equals 45. What are we going to do to solve this? Yeah. We want to get rid of 21. And whatever we do from one side, we've got to do to the other. Those are going to cancel out. Now I'm going to bring down my x equals, what is 45 minus 21? 24. Okay. How are we feeling about that whole process?
I feel better now.
Feel better now? Good, good. Okay, I'm going to throw you something different now. What about an equation like this? We're not doing x plus a number, we're doing x minus a number now. So my problem here is x minus 3 equals 2.
Are we adding now?
Yeah. Whatever we have here on this side next to the x, we need it to cancel out. So in order to get rid of a negative 3, what are we going to do? Yeah, we're going to add 3 here. So I would do plus 3 right here. And what else do I need to do to keep this equation balanced?
Plus 3 on the other side.
Yes, I need to also add 3 on the other side. So what happens with my minus 3 and my plus 3? They cancel. They cancel. Very good. And what I'm left with now is x equals, what's 2 plus 3? 5. Good. So if we were to look back at our original equation, x minus 3 equals 2, we could plug in our answer and make sure we did it properly. We got x equals 5. Is 5 minus 3 equal to 2?
Mm-hmm.
It sure is, so we did it right. We did it right. How about something like this? X minus 10 equals 15. What would I do to figure out what x is?
Add 10 to the cell.
Yes, we need to add 10 because we have a negative 10 here or a minus 10. In order to make that cancel out, we need to do the opposite and add it. Positive 10 and negative 10 cancel out. Whatever we do to one side of an equation, we have to do to the other. So we're going to add 10 to this side too. So now we have x equals, what's 15 plus 10? 25. Good. And we know we got the right answer because if we plug 25 in for x, 25 minus 10 is the same thing as 15. Those are equal, so we know we did it correctly. Okay, let's do another one together. Let's try one where our answer is on the other side. We're going to do 17 equals x minus 20. So remember, we're trying to figure out what x is, and in order to get an answer of x equals something or something equals x, we need to get x by itself. So what should I do here to get x by itself? Yes, we have a minus 20. Let's do plus 20 to get rid of it. So those cancel. We've got to do the same thing to the other side. And then what am I going to do?
Add 17.
Yeah, what's 17 plus 20?
37.
37. Am I done?
No.
No, what else do I need to do?
Equal x.
Yes, equals x. I want you to have your x is equal to something circled, just like that. Okay, let's do one more, and then I'm going to have you try on your own again. How about 12 equals x minus 21. Okay. What's our first step? Add 21. We want to get rid of it. So to do that, we need them to cancel out. So negative 21 and positive 21, those two cancel. Now what do we do?
Add 12
Yes, and what's 12 plus 21? 33 equals x. And then we circle it. Perfect, guys. That is wonderful. All right. I want you to try these on your own. Let me see if I can get all these to show and still let you see some of the work. I want you to do numbers 1 through 4 on your own. And I'm going to pause the recording again and I'll set a timer. Okay, so for numbers 1 through 4, you're going to notice that I did a little mixture of addition and subtraction because I wanted to see if we could recognize the difference after learning about both separately. So let's start with number 1. We have x minus 5 equals 13. So what do I need to do to solve for x? Yes, we need to add 5 to both sides. When we add 5 to a minus 5, those 5s are going to cancel. All right, now we can bring down x equals, what is 13 plus 5? 18. Perfect. Did anybody get something different here? What'd you get?
That's okay.
What'd you do different?
Okay, nothing. I just got it wrong.
That's okay. So I actually love it and really encourage it whenever we do something wrong because odds are you're not the only one that did it wrong. And I love to hear what we did so that we can correct it together.
When the numbers on the other side are equal, that's the one you take over?
Mm-hmm.
Okay, whatever's on the other side of the equal, that's what you break down.
Yeah, so whatever you're doing, basically, let me draw it out.
I know I made a mistake here.
That's okay. I'm going to draw out kind of a visual guide again, just because I think that this will help everybody. With this equation, we had x minus 5 is equal to 13. So remember, what we're doing here is we're trying to figure out what number we can put for x to make these sides equal. Okay, I like to think of it like a balance, like a scale. So over here I have 13. Over here I need to have some number minus 5, and that whole value needs to also be equal to 13. So in order to figure out what number is going to go in there, we're going to take that 5 away. We're going to do that to both sides. Remember, whatever we do to one side, oh, plus 5, sorry guys, plus 5, whatever we do to one side, we got to do to the other. And this is a different way to look at it. Y'all don't have to do this. Those are going to cancel out, our 13 and our 5. Now we're going to have an 18 here. So we know that when we put in 18 for x, if I have 18 minus 5, that's the same thing as 13. Those are equal. I feel like I might have just made it worse. I think that might have been more confusing than I meant for it to be. Okay, we're just going to move on. I'm sorry, guys. Let's look at number 2. Stop me if you need to ask a question or something, or you just, you know what, call me out. Tell me, Ms. Taylor, that don't make any sense at all. Tell me. Uh-huh. Thank you. You're so sweet. Okay, number 2, we have 21 is equal to x minus 4. What do I need to do to get x by itself? Add 4. We want the 4s to cancel. And then we've just got to do the same thing to the other side. So negative 4 and plus 4, those cancel. Now what do we do? Yeah, 21 plus 4, what is that? 25 equals x. Good. Does everybody understand how we did that? Is anybody confused about any of the steps we took?
I'm just trying, I'm still still trying to figure out which side, yeah, where all the numbers, if they're on this side equal, is that number.
Uh-huh.
So it's always the number that's wherever the equal, no matter where you got it at. It's the x and a negative 4. That 4 is what I would do.
Yes. So basically,
I did the other way. That's what I was doing. Yeah.
Right.
I gotta remember where the
Right.
numbers are. That's what I
so it doesn't matter what side the numbers are on. Your goal is always to get x by itself.
I understand that, yeah. It's just find the right number to put up.
Yes. So whatever number is over here with x, keeping it from being alone, we got to get rid of it. So on this side, we had x here and another number, and x does not want negative 5 to be next to it. So we got to add 5 to get rid of it. Just like over here, it had a minus 4 next to it. We don't want x minus 4. We just want x. So we got to get rid of that minus 4 by adding 4. Okay, let's look at number 3. We have x plus 11 equals 26. What do we do to get x by itself? Yes, we're going to subtract 11 so that we can get rid of it. We got to do it to both sides. So what is going to happen with my 11s? They're going to cancel. Now what is 26 minus 11? 15. So I am going to get x equals 15. All right. Is anybody confused about anything on number 3? Okay, if not, we're ready to move on to 4. Now we have 31 equals x plus 15. And remember, our goal is to get x by itself. So what number are we trying to get rid of?
15.
Yes, we're trying to get rid of 15. How can we get rid of it?
Subtract.
Yes, you guys are getting it. Minus 15 from both sides. All right. Those are going to cancel, the 15s. And then I'm going to have, what is 31 minus 15? 16 equals x. There we go. We solved for x in all of those. Okay, good job, guys. How do we feel about that? Good, good. I know, I think these are kind of satisfying. These are kind of satisfying. All right, I'm going to throw you a curveball. What if we had equations like this? Oh my goodness. Oh man. Okay, let's talk about this. Let's talk about this. Let's just look at the first one. Don't even look at the second one yet. We have 5x equals 20. Can anyone remind me, what does it mean when I just have 5 next to an x? What operation am I really doing here? Multiplication. This means 5 times x equals 20. So what number would I multiply by 5 to get 20? 4. Good. So we know that 5 times 4 is 20. So x must be 4. Okay, so we did that. Good job. But let's talk about how we would solve it by writing it out. Because it's not always going to be a pretty number like 5 times 4. I think we knew it was 4 because we just knew 5 times 4 is 20. Let's talk about what we would do to solve this without just knowing the answer. So in our previous problems, when we had something like minus 5, we wanted to get rid of it, so we would do plus 5. When we had something like x plus 11, we wanted to get rid of that 11, so we would do minus 11. If you notice, we're just doing the opposite here. So if I have something like 5 times x, we need to do the opposite of multiplication to get rid of the 5. Does anybody know what the opposite of multiplication might be? Division. Division. So here's what we would do. We're going to divide by 5 on both sides. All right? My 5s are going to cancel because 5 times 5 is 1. Or divided by 5. My bad, guys. And we know that whenever we have 1x, it's the same thing as just x. So I'm going to rewrite x down here because I canceled my 5s out. Drop down my equal. And then what is 20 divided by 5? 4. And look at that, guys. We got the right answer. X equals 4.
So are we able to do it either way or just?
Absolutely. Let's look at another one really similar. Let's do 30 equals, let's do 2x. Okay, so we have 30 is equal to 2 times x. To get rid of the 2, what am I going to have to do? Yeah, we're doing multiplication here. 2 times x. The opposite of multiplication is division. So we're going to divide by 2 on both sides. My 2's are going to cancel. So now I'm going to have a number equals x. What is 30 divided by 2? That's all right. 15. We got 15 equals x. And if we wanted to check to make sure we got the right answer, we can plug that 15 in to our original equation. We know 2 times 15 is equal to 30. Yeah. Good job, guys. Let's do one more like that. How about 27 equals 9x. Remember, our goal is always to get x by itself. That's our goal. We want x by itself. So if on this side of the equation I have 9 times x, what do I need to do to get rid of the 9? Yes, we're going to divide by 9 on both sides. What's going to happen now? Yes, my 9's are going to cancel out. I'm going to bring down my x. And then what is 27 divided by 9? 3. Good. So we know that x is 3 in this case. Okay, how do we feel about that? Pretty good. Good. Awesome. Okay. One more thing to show you. Boop. What if we have this? X divided by 5 is 10. When we had a multiplication problem, we divided to get rid of it. What if we have a division problem? We're going to multiply. We always do the opposite. So to get rid of this 5, because I'm doing x divided by 5, I'm going to multiply by 5 on both sides. My 5's are going to cancel. Then I'm going to get x equals, what's 10 times 5? 50. X equals 50. And we can check to make sure that's right. If I do 50 divided by 5 from my original equation, is that equal to 10?
Yeah.
It sure is. It sure is. How about one more like that? X divided by 2 equals 12. What's our goal, first of all? What's our goal?
Oh, to get the x back.
Yes, we always want to get x by itself. So how do we do that here? Yes, we have x divided by 2. We need to do the opposite and multiply by 2 to both sides. Okay? What happens with my 2's?
Cancel.
They cancel. So I'm going to get x equals, what's 12 times 2? 24. Good job, guys. You're really getting this. That's awesome. Okay, so before I give you an exit ticket today, I want to just introduce one more little concept. It's not a different type of problem. Don't worry. We've done all of the math we're going to do today. That's it. Here is what I want to show you. What we've done today, where we are doing kind of the opposite of whatever we see in the equation, we're going to call that inverse operations. Everybody say inverse.
Inverse.
Operations.
Operation.
Good. Inverse operations just means the opposite, whatever you're doing, multiply, divide, add, subtract. So we're going to make a quick little chart to help us remember. So here I have addition. What is the opposite of addition? Subtraction. Good. Now one more. What do we have here? Multiplication. Now remember, multiplication will sometimes be an X, sometimes it'll be a dot, sometimes it'll be numbers in parentheses, like that. Those are all ways to write multiplication. What is the opposite of multiplication? Division. Good. And again, sometimes division is written like this with our division symbol. Sometimes it'll be, here, let me kind of label this, a number over another number. Sometimes it will be a number with a slash and then a number. Just remember, anytime that we have division, just like we see in this symbol, it's going to be a number, a line, another number. That's all division ever will be. So, anytime there is multiplication in a problem, we need to divide to get rid of it. Anytime there's division in a problem, we need to multiply to get rid of it. If there's addition, we use subtraction. If there's subtraction, we use addition. To solve for x and get it by itself, we always use these inverse operations. Always. Okay, guys. I am going to give you your exit ticket. Day 14 exit ticket.
Don't take our extra tickets home.
You absolutely can. I know, we're kind of cutting it close. We got 3 minutes left. For your exit ticket, remember, we have a whole week to turn them in. So today is Wednesday. As long as you get them to me by next Wednesday, that's totally fine. So I'm going to have you do one of each kind of problem. Number 1, let's do x plus 10 equals 25. Number 2, let's do 15 equals x minus 3. For number 3, we'll do 5x equals 35. And number 4, let's do 3 equals x divided by 2. Okay. Those are your 4 questions for your exit ticket today. Remember, if you don't finish it before you leave, that's fine. That's fine. I know we kind of took a lot of time today. That survey in the beginning took a lot longer than I thought it would. So that did steal a little bit of our time. And if you are still feeling a little bit shaky or unsure about today's lesson, remember they will be posted on YouTube. So if you want to go back and watch this again, you can check Google Classroom, or you can just search what I have on the board at Taylor Teaches Math Excel on YouTube. Okay guys, that is all. Thank you.